We're given this logarithmic equality and we're told to solve for x. So the first thing we notice is that both of these logs have base 3. So we can combine them with the logarithmic property for addition. The log of a plus the log of b is equal to the log of a times b. So we can say that this is equal to the log base 3 of x plus 1 times x minus 1 equals 2, like so. Then we can FOIL this guy inside here. So this will be log base 3. X times x is x squared, so we have x squared. X times minus 1 minus x. 1 plus x, so plus x. Plus 1 times x plus x. And then plus 1 times negative 1 is negative 1, like so. And this is equal to 2. So we see these x's canceling, and we get the log base 3 of x squared minus 1 is equal to 2. Now, up until now, all we've been doing is clarifying the left-hand side of the equation. And because we've just been doing clarifications, we haven't had to make any changes to the right-hand side of the equality. So, okay, now we're going to raise this thing 3 to the power of this, and then do the same thing on the other side, 3 squared. So 3 raised to the log base 3 of x squared minus 1 equals 3 squared. It's an awkward thing to say with words, huh? 3 raised to this. It's not like log base 3 of 3. So, okay, so then because this number is equal to this number, because we see like bases here, then the argument drops out. We have x squared minus 1 is equal to 3 squared is 9. I had 1 on both sides. Plus 1, x squared is equal to 10, like so. Taking the square root of both sides to get x by itself, we see that x is equal to plus or minus the square root of 10. But that's not the end of the story, because let's come right here. What this says is x is equal to plus positive square root 10, which is approximately equal to positive 3.16. So this is approximate. Or x is equal to negative square root 10, which is approximately equal to negative 3.16. Let me check that. It is correct. Okay, so now that we have these two roots here, let's take a look at the initial equality and see if these will plug in and satisfy the initial equality. Well, notice this negative root, and you always want to check the negative root. That's usually the one that's going to be the problem. So let's take a look at this negative root. If we put negative 3.16 plus 1, we get negative 2.16. So you cannot take the log of a negative number. It doesn't matter what base it is, log base e, log base 10, log base 7. No, there's no base of a log where you can take the log base something of a negative number. So that means that this is an invalid solution, and the only solution to this problem is x is equal to positive square root of 10. Okay, I'm going to step out the side and give you a clear screenshot.